of equal length as shown. Find the tensions in the two strings when the system is in equilibrium. So look at the construction. The two strings have tensions T1 and T2, and the third string is attached to a block of mass 5 kg. The question is tensions in the two strings when the system is in equilibrium. This first string and this is second string, and the angle between them is 90 degree. This tension is T1, this tension is T2, and this weight is nothing but m into g. This weight is m into g. So how much is that? Weight is equal to m into g. What is the mass? 5. 5 into 9.8. So I'll just retain it in this form. That is 49 Newton. Now this is alpha, this is beta, and this is gamma, which is 90 degree. Now as the lengths are equal to each other, the two strings are of same length, can we say that alpha and beta are equal to each other? Yes. Why are they equal? Because the two strings are of equal length. Geometry tells us that if these two heights are equal, the angles are also equal. And the total angle of this circle is 360, out of which 90 is gone. So we're left with 270, which means 135, 135 each. Now it's a simple job. T1 divided by sine 135 is equal to T2 divided by sine 135, that is equal to mg, that is 49 divided by sine 90. So do you notice that T1 and T2 are equal to each other? Yes. So I'll take the first term and the last term. That gives us T1 is equal to sine 135 into 49 divided by sine 90. Sine 90 is 1, sine 135 is 1 by root 2 into 49. That becomes 34.6 Newton, and T2 is also equal to T1, which is 34.6 Newton.